Welcome back. This is an Aleks training video on writing the rate law of an elementary reaction. Remember, elementary reaction doesn't mean an easy reaction. It means a one-step reaction. That's all elementary means. And so when you're writing the rate law, it's simply based on the concentrations of the reactants. So the concentrations are in brackets. It refers to the molarity, or how many moles per liter each of the reactants are. They're multiplied together and then multiplied by a constant, which is just simply a number that makes all the math work. So you're going to have something like K1 times concentration of first reactant times concentration of second reactant. Very simple. You are going to need to tweak it just a little bit. If you look to the right, I've given you a couple examples, and then we'll do the one that they ask us. So looking over here, I've got bromine gas breaks apart, okay? Br2 is a molecule, so it breaks apart into two bromine ions, and that's a reaction, okay? If you were writing the rate law, it's only based upon the reactants, and so Br2 is your reactant. It's the only one reactant, so it's going to be, your rate law here would be K1, some kind of constant, times brackets the concentration of Br2. Easy, easy, okay? Now, the reason why that this is not modified is because this is not modified. It's all based on the balanced equation. So if you look to the balanced equation and you've got a coefficient, suddenly that coefficient is going to show back up as an exponent. Okay, so if you're writing the rate law of this second example, two hydrogen atoms are going to come together to form a hydrogen molecule. Okay. There is your reaction, there's your balanced equation. The rate law of how fast that's going to happen is only based in hydrogen. Hydrogen is your only reactant, so it's going to be your only part of the rate law. But there's two of these for every one molecule of H2, and the rate is going to show back up. This coefficient 2 is going to show up as the subscript or the superscript of the hydrogen. So it's the concentration of the hydrogen ions squared. Okay, so whatever that concentration is times itself times some kind of a constant will be its rate law. Okay, so you're looking not just at reactants. Okay, so you're looking, the balanced equation tells you the rate law. Then you look only at the left side, and each reactant contributes a term. Okay, so for instance, in this third one, I've got two reactants. Okay, so you're going to have two terms in this rate law, and then each stoichiometric coefficient, which is like this 2, is going to contribute an exponent. Okay, so if you got a 1, which is not shown, you have a 1, it's only to the 1 power, which is not shown. But if you have a 2 something in the balanced equation, it's going to show up as a 2. So let's look at this one. I've got two terms in the reactants. That means I'm going to have two terms in the rate law, some kind of a constant K1 times the concentration of H in molarity, the concentration brackets, times the concentration of Br2. And that's it. Okay, this is simple stuff. This whole chapter is easy. And then the last one here, I've got H2 plus 2Br. Okay, so I've got a coefficient. I've got a coefficient here. Now remember, you're only looking at the left. So I ignore this. I'm only looking at the left. I have two terms in my rate law. The first one is going to be the brackets around the H2. So you have a constant K1 times the brackets around H2 times the brackets around Br. But since I've got a coefficient here, it's going to be a Br2. All right. So this should help you because I don't know which ones you're going to get. I don't know what balanced equation you're going to have. And my guess is you will have some that have coefficients, and your rate law is going to have powers. All right, so let's see what this one is. I think this one's actually pretty simple. Looks like it. I've got some kind of ethane plus chlorine. We'll have some kind of a ethylene chloride plus some kind of a chloride ion. So it's breaking apart, whatever the reaction is. All right. The rate law is only based upon the left side. So you're just looking at the left side. The left side has two terms. Okay, there's two reactants. I've got this one and this one. All right, so let's let's see what we can do. The rate law will be rate equals, okay, now some kind of a constant, K1 times the concentration of the first reactant, CH2CH2, times the concentration. Now that's raised to the power of the coefficient. So I'll look over here. I don't have a coefficient. I just have a coefficient of 1. That means I'm going to have a coefficient of 1 here. So I don't write it down. All right, and now continuing, I have the second reaction, which is the chlorine. It's a chlorine molecule, Cl2. It's raised to the coefficient of it's raised to the power of its coefficient. I don't have a coefficient here, at just a 1. That means this is going to be a 1 power here, and that's the rate. Rate equals K1 times the concentration of the ethane times the concentration of the chlorine. Okay? Like this, I think you can do it.